Hello students, we'll start with the first chapter of logical reasoning. Like you see on the screen, the chapter number 1 in logical reasoning, which is number series. There is coding and decoding, and also there is odd man out. There's nothing much to explain about the chapter, so we'll directly see what are the things that we'll be learning in this particular chapter, and it goes without saying there are 3 parts. There is number series, coding, decoding, odd man out. Like in mathematics, I had to explain something about a particular unit, but here it's all the logic that we'll have to use. We'll have to find some patterns, use little bit of logic. The number ka logic from one number to another number, there will be a sequence and all of that. What exactly it is, we'll see in the questions. But just to give a small brief, there will be addition, there will be subtraction, there will be multiplication, there will be division. And combinations of these, then we'll also have odd numbers, even numbers, prime numbers, all of these things related to numbers. Fine, we'll take up the questions. Question number 1. If you see the first question, there is 6, there is 11, there is 21, there is 36 and 56. See, if the numbers are increasing, it has to be either addition or multiplication. And the numbers are decreasing, it has to be either subtraction or division. Correct? So we'll try with the multiplication first, because I see 6, there is 11. It's not a direct multiple, but then I know 6 to 11 is into 2 minus 1. Right? Let me write that. I'm not saying it is right. Let me just check. So we have 6 as the first number. First number into 2 if I do, I get 12. Then if I do minus 1, I get 11. First I have to get some logic, and then I have to make sure the same logic continues. So if I take the next number 21, next number should be 21. That means my answer should be 21 if I use same logic. So if I take 11 into 2 minus 1, 11 into 2 is 22. 22 minus 1 is 21. Works. So I'm very happy I'm getting the answer. But if you continue, 21 into 2 is 42 minus 1 is not equal to 36, which is the next number. So this logic is wrong. So the very first problem, first thing that I'm trying is to give you logic which is wrong. Now let's try to find the right answer. I told you if the numbers are increasing, it should be either addition or multiplication most of the time. Correct? Okay. So we'll take the relation from the first number to the second number. So we have the first number over here. We have plus something which should be equal to 11. Correct? What is that? Something which is equal to 5. Now, if you take the next number is 21. You should get answer as 21. I will continue from the previous number. We have 11 plus something which is equal to 21. 11 plus 10. 11 plus 10 is 21. Great. So first time we added 5. Second time we added 10. Let me check the next one. 21 plus something, answer should be 36, because next number given is 36. And what should that be equal to? That is equal to 15. Okay, we have 36. Next number is 56. Let's check that. 56 plus something which is equal to 36 plus something should be equal to 56, which is 20. By now I know the numbers that I'm adding to the previous number are going in a sequence. 5, 10, 15, 20. Correct? Okay. So in that case, what can I do? See, from over here we have 11. We have 5. From year to year we added plus 5. Correct? Also from year to year also we added plus 5. So every time we are adding 5. From year to year we are adding 5. So if I add another 5 to 20, it becomes 25. This should be 25. Okay, and the number is 56. So I'll write 56 over here plus 25. 56 plus 25, which is equal to 81. 81 is there. 81 is the right answer. So fine, in the first question we tried multiplication, didn't work. Then we went for addition, worked perfectly. And that's the first answer. Answer is 81. Fine. I'll move on to the next question now. Okay, question number 2. In the second question we have 10, 100, 200, 310. This time We'll try addition on the first. So we are starting with 10. We have to reach 100 and we have to add 90. Is that right? Yes, it is. Then from 100 we have to reach 200 and the difference between these two numbers is 100. Great. And the next one, 200 plus something should be 310, which is 110. So we are using the almost same logic as the previous one. So we added 90 for the first time, we added 100, then we added 110. So how much should I add in the next one? So we are from year to year 90, 100. So we add plus 10 to be added. From the second one to third one, we add another 10 to be added. And from here also we should add another 10. So 110 plus 10 is 120. You add to the previous one, that is 310. 310 plus 120, 430, which is there in option C. Option D. Option D is the right answer. So same thing, same logic again, we are adding and getting the next number in the sequence. Fine, that's question number 2. We'll move on to the next question, question number 3. Great. We have 120, 99 and a missing number. So it is difficult for us to find the logic right away. Like, see if I take the difference and then immediately I have to find the answer. So what I would do over here is, we'll start from the other side. We'll start from 35. We'll start from 35. We'll see what is the connection from 35 to 48. I'm coming backwards. And 48 to 63. And then we'll find the missing number and see if the logic is working. Great. Okay. So 35 to 48. What is the connection? 35 plus something should be equal to 48. How much is that equal to? That is 13. Correct. Okay. Next, from 48 to the previous number 63. 48 plus something should be equal to 63. What is that equal to? That is equal to 15. 48 plus 15 is equal to 63. So I'm seeing that from 13 we went to 15. Okay. So maybe I'll have to add 17. Correct. We'll check with the other numbers also how it works. We'll have to check 17. If I add 17 to 63, 17 plus 63 is equal to 80. So maybe my answer is 80, but I have to make sure it is continuing, the sequence is continuing. So we have 80 plus, now we have to add 19, right? With that logic, 13, 15, 17, 19, and that should be 99. And 99 plus 21, which is 120. So the answer that I had got earlier, this answer is right. We added it rightly. This answer is right. Answer is 80. 8 is the right answer, which is there in option A. Fine. So with that, we'll move to the next question. Question number 4. So first question we took addition, second also addition. Here I can actually say subtraction because if you use from starting, but then I started from the other side and still got addition only. Moving on to the next question, question number 4. 4,832, a big number. Let me just find the difference between this. We have 4,832 minus 5,840. You can do it the other way around, and the difference is 5,840 minus 4,832, and the difference is 1,008. 4,832 plus 1,008 is equal to 5,840. Okay, and now from the second number, let me check. 5,840 plus something should be 6,848, and that would also be 1,008. Again, the difference is 1,008. Now this time the difference is constant. The difference is same from first to the second. So the third one we'll check. 7,856, and if you take the difference with the previous number, in fact I wrote it little wrongly, should have written it here. Okay, the previous number 7,856 should be my answer. Previous number is 6,848. Again the difference is exactly same, 1,008. So what should be the next one? Next one I'm gonna add exactly the same number, 7,856 plus 1,008. 7,856 plus 1,008, and I get 8,864. which is there 8864 in option A. Option A is the right answer. So the same difference is there between the numbers. Quickly moving on to the next question. Question number 5. Okay, so we have 28. We have 33 to get. It is increasing, 28 to 33 it is increasing, and we know it is plus 5. 28 plus 5 is 33. But if you see over here, after 33 it is decreasing. 33 minus 31. 33 minus 31 is there. 33, 31. The difference is 2. Minus 2. So we have addition, then we have subtraction. But from 31, the next number that we see, 31, we should get 36. What should we do? Again we have plus 5. So we add plus 5, then we have minus 2, then we have plus 5 again. Let's check. We cannot conclude so fast. Okay, we have 36 and we have to reach 34, the next number. This is again minus 2. Fine, let me continue over here. Okay, we have 33, 31, 36, 34. If you see the sequence over here, we have plus 5. After plus 5, when it goes over here, it becomes minus 2. So the sequence is plus 5, then we have minus 2, and then again we have plus 5, and then again we have minus 2. Correct? It is moving that way only. So in that case, what should we do? The next one should again be plus 5. Continuing the sequence, plus 5 minus 2, plus 5 minus 2. So we had 34. The last number was 34. 34 plus 5, which is equal to 39. Do we have that? We do have 39, which is given in option B. Answer is B, 39. Great. So the sequence has changed now. We are using addition as well as using subtraction. Both are used simultaneously. Moving on to the next question. Okay. Question number 6. We have 4, we have 9, we have 25, we have 49. Okay. Then there is a missing number. 169, 289, 361. First, it looks like we have to add or multiply. I told you the numbers are increasing. Fine. But if you actually see, these numbers look comfortably something like we have used it before. 4, 9, 25, 49. What are these? These are perfect numbers. In fact, they are perfect squares. We have 4 which is 2 square. So we have 4 equal to 2 square is equal to 4. We got the first one. 9. We have 3 square is equal to 9. Great. And the next number is not 4 square. It is 25, which is 5 square. So 4 is missing. Let's continue. The next number we have is 49. 49 is 7 square. So we have 2 square, 3 square, 5 square, 7 square. Something is missing. Then we have 169, which is 13 square. And after that we have 289. What's 289? Which is 17 square. Correct? And then we have 361, which is 19 square. So we know these are perfect numbers. We know these are perfect squares. But somehow it is not the every number square that we are taking. We are taking 2, then we have 3, then we have 5, then we have 7, then we have 13, 17, 19. So something else should have been there. Some other sequence is there between these numbers. Are they all even numbers? Absolutely not, because 2 is even, remaining are odd. Are they only odd? That also cannot be. So other than odd numbers, even numbers, do we know something else about numbers? Yes, we do have prime numbers. We have prime numbers, correct? What are prime numbers? Prime numbers are not the product of any two numbers. Fine? Okay. They're not divisible. Correct. That's the right definition. So we have 2, 3, prime number 5. The next prime number is 7. After that, the next prime number after 7, 8 is an even number, which is a multiple. 9 is not a prime number. 10 is not a prime number. We have 11. We have 11 square, which is equal to 128. 1. 121, do we have that? Yes, we do. Option B, 121 is the right answer. So we are now gone into perfect squares. We have also got into prime numbers. Great. We'll move on to the next question. Okay, question number 7. Just clear this to move to the next one. Okay, question number 7. We have 4, we have 12, we have 36. 4, 12, 36. Numbers are increasing. Then there is a missing number. Then we have 324. Let me try to get some logic. Looks like it's multiplication right away. 4, we need to get 12. 4 into 3 is equal to 12. And then we have 12 into 3 is equal to 36. Looks like we just have to multiply with 36. Sorry, multiply with 3. 36 into 3, which is 108. That is there in the options, but let me wait for the confirmation. It is 108 into 3. 108 into 3 is equal to 324. We already have an answer. The logic is right. We just have to multiply with 3. Answer is 108. That's question number 7. Moving on, question number 8. We have 1, we have 1 again, we have 4, we have 8, we have 9, and we have a missing number 16 and 64. What do you know about these numbers? So we have 1, I know, repeat it again, but then after that we have 4. Okay, 1 and 4 are perfect numbers, perfect squares. Then we have 9, then we have 16. So let me just circle them. Fine, we have 1, we have 4, and alternate numbers, we have 9, we have 16. These are perfect squares, correct? So ones which are there in this, that is circle, red color one, these are perfect squares. These are perfect squares. Now let me just change the color. Okay, now the remaining numbers, that is, we have 1 over here, we have 8 over here, we have a missing number, and we have 16. What do you think these are? 1, 8, and 64. What are these? These are perfect cubes. Blue color in square, we have perfect cubes. We have perfect squares, we have perfect cubes. So we have 1 square, 1 cube, 2 square, 2 cube, 3 square, 3 cube. What is 3 cube equal to? So in that case, the missing one is 3 cube, which is equal to 27. Do we have 27? Yes, we do. 27 is there in option A. 27 is the right answer. That's question number 8. So it was a combination of perfect squares and perfect cubes of natural numbers. Perfect. We'll move on to the next question. Question number 9. We have 5,760 and we have to reach 960. The numbers are reducing, and if you see the next number, it's not reducing as much as it is reducing in the previous one, so may not be subtraction. We'll try the division first. Okay, let me divide and check. We have 5760 divided by 960. I get divided by 6. Divided by 6. Okay, then next one we have 960 and then we have to reach 192. 960 divided by 192, which is equal to divided by 5. So we are not dividing by the same number, we are dividing with a different number. Then from 192 we have to get a particular number. We have to divide with a particular number and also get the answer. Fine. And then we have 16. We have 16. So when you divide by this number, you should get 16, and then we should get 8. Correct. This is what we know. This is what we know. From here we'll have to do some reverse calculation. Maybe. Fine. Okay. Okay. Here we are over here. Now I'll write the relation from here. So this becomes 16, right? Reverse calculation. 16 divided by 2. 16 divided by 2 is equal to 8. Perfect. 6, 5. 2 missing numbers, and then we have divided by 2. What do you think it should be? From here to here, 1 less 6 to 5, we have minus 1. So then we should get divided by 4 divided by 3. Then we have divided by 2. Correct. In that case, what should this number be equal to? 192 divided by 4, which is 48. 8, correct? 48, we get 48. Do we have that option? But let's confirm. If you take 48 over here, 48 and then divide it by 3, we get 16. So a little bit of reverse calculation and we have got the right answer. Answer is 48. This was the missing number, wasn't it? So 48 is the right answer, which is there in option B. Perfect. Okay, we'll move on to the next question. Question number 10. Question number 10. We have finished 9 so far. Great. So we have 1, 2, and then we have 6, 7. We have 21, 22. So we have a particular difference in between, but after one number it is consecutive numbers. What I'm saying is 1 to 2 are consecutive numbers. Then we have 6, a jump. Then we have a consecutive number 6 and 7. 7 there is a jump, and the jump is also not same. Okay, so we'll take the first number, consecutive number 1 plus 1, which is equal to 2 consecutive numbers. Then we have 2, we should get 6. Numbers are increasing, so for the timing I'll just write into 3, which is equal to 6, and then I have a consecutive number 6 plus 1 is equal to 7. So I have to take this 7, and now if I have to get the same logic, 7 should be again multiplied with 3. 7 into 3 is equal to 21, correct? So 21 ka next number plus 1, 22, which is there, 22 is there. Then we have 22 into 3, which is 66. Okay, working. And the very next number 66 plus 1 is equal to 67. 67 is the number that I was looking for, which is there in option C, 67. Perfect. We'll move on to the next question. Question number 11. 48, and then it comes down. 48, we need to come to 24. Simple, divided by 2. May work, may not work, we'll see that later. Then we have 24, we need to reach 96. 24 to 96, it's a multiple, correct? So into 4. So divided by 2 into 4, and the very next number is missing, correct? So I'm not very sure. We'll try this. We'll divide this by 2 again, because first we divided by 2, then we add into 4. Now next we will take 96 divided by 2, we get 48. Though we have the option, let's not jump into the conclusion. Yes, it is there 48, but let's not jump into the conclusion. Maybe the logic is different. Let's see. We have 48 into 4, because alternatively we have to multiply with 4. Divided by 2 multiplied with 4. 48 into 4 is 192. Since you have only 4 numbers, looks like the logic is right. Answer is 48, which is there in option A. Moving on to the next question. Question number 12. 2. Then we have 3. Okay, very next number, consecutive number. Then 3 and the very same number is repeated again. And then we have plus 2, right? 3 plus 2, 5 we have. And then we have again double of that. Then we have again little nearby, right? 10 and 13. But after that again we have a jump, 39. So what's the pattern that you see over here? So we have 2. We have to get 3, right? So I'll write into 1. Sorry, plus 1. 2 plus 1 is equal to 3. Correct? I will take that 3 number and write into 1. I'll still get 3. So somehow I got the logic for the first 2. But remember, we have to continue this. Next number that we have is 5. We have to get answer as 5. The last number that we got is 3. And I should get 5. So what is the logic? Plus 2. Oh, logic is changing everywhere. Let's check if it continues. We'll take the last number now, 5. We should get 10. This I know for sure is into 2. Wait, I think I'm getting a logic. We had plus 1 into 1. We had plus 2 into 2. Maybe we are there. We take the last number, we do plus 3, which is 13. And we take that number and multiply with 3, which is equal to 39. That's the reason they have given us so many numbers. They're giving us time to get the logic. So now we have got it. Now we have 39 into 4. Let's check that. 39, in fact it should be plus 4, right? Yes, which is plus and then multiplication. 39 plus 4, which is equal to 43. Let's just confirm if it is holding good. 43 into 4, Is it equal to 172? Yes, it is. And then 172 plus 5, which is equal to 177. So the logic is right. It was into 1, before that plus 1 into 1, and then it was plus 2 into 2, then we had plus 3 into 3, plus 4 into 4, plus 5 we reached, and that was the end of the series that is given. If we had to continue, it would have been into 5, but not required. We have the answer is 43. Moving on, number 13, we have 7. After 7 we have 26, then we have 63, 124, 215. Numbers are jumping, right? So it cannot be addition, looks like that. Maybe something to do with multiplication. 7 into 4 is 28. The next number is not a perfect, not a multiple. 7 into 4 is 28. If I have to reduce to it, comes to 26. 26 to 63. First we multiplied with 4. So we can multiply maybe with 4. No, it's a bigger number. Multiply with 3, still a bigger number. Multiply with 2. So it's not matching. So it's not multiplication directly. So there must be something else to do with it. So we have 7, 26, 63, 124, 215 and 511. So when I see 511, this looks like a number close to a number which we are comfortable with. There is 124, a number which we are comfortable with. I am talking about perfect squares. So what are the perfect squares? In fact, they are perfect cubes, not perfect squares. They are perfect cubes. What are the perfect cubes now? We have 2 cube which is equal to 8. We have 3 cube which is equal to 27. Correct? 2 cube is equal to 8. 3 cube is equal to 27. We don't have these numbers. We have one less than that. We have 7. We have 26. What is 4 cube now? 4 cube is 64. But we have 63, one less than that. Correct? So we have 5 cube equal to 125. The number is 124. And then we have 6 cube. 6 cube. What is 6 cube equal to? 6 into 6 into 6? 216. Minus 1. 215. So we have that as well. So this should be 7 cube. Let's find 7 cube now. 7 into 7 into 7, which is equal to 343. But we need minus 1. So we have 342 as the answer. But let's check the next number as well. We have 511. That should have been 8 cube, right? 8 cube is 512. So the logic over here is we cube the numbers. Cube numbers and then minus 1. So what we have studied so far is we have to add somewhere, use subtraction, division, multiplication. We have perfect numbers, we have perfect squares and perfect cubes, and the combination of all of this. Different problems. Moving on, question number 14. We have 3, then we have 7. 3 into 2 is 6, but we have 7. So maybe we have 3 into 2 plus 1 equal to 7. Let's try now. So the next number is 7 into 2, which is 14, plus 1, which is equal to 15. Oh, it matches. So it becomes easier from here. 15 into 2, which is 30, plus 1, which is equal to 31. So my logic is right. We just have to multiply the previous number with 2 and then add 1 to it. So we have 31 into 2, 62, plus 1 equal to 63. Let's check the remaining number. 63 into 2 plus 1. 63 into 2. 63 into 2 is 126 plus 1 is 127. We already have the answer. Answer is 63. Just making sure that the logic holds good even for the number after we have got the answer. So what did we do over here? That number, last number into 2 plus 1. That's logic. Next one. Moving on to the next question, question number 15. We have 8, then we have 28. Correct? So we have 8 and we have 28. Some connection is required, some multiplication is there for sure. Either we'll have to multiply with 3, which is 24, or we have to go to multiply with the next number, that is 8 into 4 and then minus something. Okay, let's try with this first. 8 into 3, 24, and then we have plus 4, which is equal to 28. This is just a random pattern that I'm trying to form, and we have to make sure it satisfies for all of them. So we have now 28. Let me try now. I should get 116. 28 into something, 116. If I do 28 into 3, 28 into 3 is 84. Nowhere close. Let me do 28 into 4. 28 into 4, 112. So it comes closer, right? 112. And then we have plus 4, which is equal to 116. So now maybe we'll have to multiply. So in fact, this is multiplied with 4, right? Yeah. We'll have to multiply with the number 1 more than we multiplied with the previous one, and then add 4. Let's check this now. 116 into 5 plus 4. If this satisfies, then I know the logic. 116 into 5 plus 4, which is equal to 584. Yes, I got the logic. And now 584 into 6 plus 4. 584 into 6, 3504 plus 4, which is equal to 3508, which is there in option D. 15 done. So we are combining addition, subtraction, multiplication, division, perfect square, perfect cube, and combinations, and all of this. Different patterns. How do we get it? We need to practice a lot of questions. I'm solving quite a few. Should be enough. But if you get more questions, pick the questions and keep solving more and more, you will get the logic. Moving on, question number 16. We have 2, we have 7, we have 27. Oh, 7s are there. Goes on. Let's see, we have 2, we have to reach 7. So we add 5 over here, we get 7. Simply, right? Like whatever you want, I can write. But let me see what happens after this. We have 7, we have 27. Difference is 20. First time difference was 5. Second time difference is 20. Next, after that what happens? 27, we have to reach 107. What is the difference? Difference is 80. Correct. Trying to get the logic. First time difference was 5. Second time difference was 20. Third time difference is 80. What's the connection between these? 5 into 4 is 20. 20 into 4 is 80. So it should be 80 into 4. So that is, if I take 107 plus 80 into 4 is 320. I'm taking the difference, multiplying with 4 to the previous difference. Okay, 320. That should be my answer for the next one. Does it match? 320 into plus 107 is 427. So that also holds good. Correct. I had not seen the next number. I tried to apply that logic. So in that case, what should it be? 427 plus the previous number is 320. 320 into 4 is 302 is 1200. 1280. Let's check this. 1280 plus 427, and the answer is 1707. Option A. Option A is the right answer. So what we are doing over here is we are adding the numbers, but the numbers that are added is not constant. Every time we go to the next number, we are multiplying the previous difference, that is the number that we are adding, with 4. So 5, 20, 20 to 80, 80 to 320, and 320 to 1280. That was 16. Sweet. Let's go to the next question, question number 17. We have 5. Then we have 2. Then we have 7. Oh, so it's not directly addition. Correct, it's not going in the same order. So we have 5, 2, then we have 7, then we have 9, and then we have 16. Oh, then it's following a order. 25, 16, 25 are perfect numbers, but others are not. 41 is there. Okay, but it looks like the numbers are increasing on this. So something to do with the addition. Okay, first two numbers, maybe they're not in the right order. It looks like that. Okay, so if you see 5 plus 2 is equal to 7. First two numbers if I add, I will get the third number. Now what do I do? Third number plus the second number if I do the second number, I get 9. Now this is if I take the 9 number that I got, the previous answer, if I add that to the previous number to that, 9 plus 7, the number previous to that, I get 16. Okay, so 16, I take that and then I add the previous number, I get 25. So now I take 25 and add 16, I get 41. So it holds, the logic is holding. So we'll take 41 and add the number before that, that is 25. 41 plus 25 is 66. So the question was right, the order was right. Okay, 5, 2. So basically the number is the summation of the previous two numbers. Number is equal to summation of previous two numbers. Fine. Answer is 66. 18. 0. We have 1. From 0 we have to reach 1. Then from 1 we have minus 1, 0, minus 2, minus 1. It continues. Try to get the logic over here. Okay, 0. So we have plus 1, 0 plus 1 is 1. Easily I could have written that. Okay. Now from 1 we have to reach minus 1. From 1 if you have to reach minus 1. 1, 0, minus 1. So we need minus 2 over here. But now from minus 1 we have to come back to 0. Next number is 0. So I have plus 1 over here. Okay. And now from 0 I have to reach minus 2. So again minus 2. Correct? You're getting it? First it was plus 1, then it was minus 2, then it is plus 1, then it is minus 2. Correct? So it should be plus 1 again. So let's check minus 2 plus 1. You get minus 1, which is the next given number for us. Minus 1 is given. So now what do we need to do? This minus 1, minus 2. The pattern says plus 1, minus 2, plus 1, minus 2, plus 1, minus 2. And the answer is minus 3. Option B. Option B is the right answer. Minus 3 plus 1, minus 2 plus 1, minus 2 plus 1, minus 2. That's number 18. Moving on to question number 19. Looks simple, right? Because these are all products only, I believe. 5, 10. Oh, 10 is repeated. And double of 10 is 20. Then 20 is repeated. 20's double is 40. 40 should be repeated. Answer is 40. So basically we are doubling it, repeating it. Doubling it, repeating it. That's it. This answer is quite simple. Question number 19 answer is 40. Moving on to the next question, we have 4, 8, 32, 256. Something to do with 2 for sure. Correct? So we have 4, which is 2 square. 2 square is 4, correct? Yes. Then we have 2 cube. 2 cube is equal to 8. What is 32? 32 are 2 to the power 5. These are perfect numbers of 5. 4, 8, 32. Okay. And then we have 256. 256 is 2 to the power 8. So it is not like directly we are taking powers of 2, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 4 is missing. Then if you see 2 to the power 6 is missing, 7 is missing. So what is happening over here is 2, then 3. Difference is 1. 3 plus 2. Difference is 2, 5. 5, then we add 8 directly. Difference is 3. So in that case, this should be 2 to the power, that's right, 12. Are you getting the logic over here? So we add 2, from 2 we add 3, difference is 1. And from 3 we jump directly to 5. 3 to 5 difference is 2. And from 5 we came to 8. That is difference of 3. And from 8 we came to 12, difference of 4. So now we need 2 to the power 12. 2 to the power 12 is equal to 4096, which is there in option A. That's question number 20. Moving on to the next question. Question number 21. We have 1, we have 3, we have 7, 51. The numbers are increasing, so it has to be addition. probably multiplication, but I think the numbers are jumping much more than multiplication also. So probably we'll have to square. Let's see if you square. We have 1 square is 1, little more than that. 3 square is 9, very close to 7 square is 49, very close to that. So it's very close to the square numbers. Let me try to establish some logic over here. The first one we have is 1. Okay, let me just write that. And the second number is 3. From 1 I have to reach 3. Okay, not very sure. Second, after that we have 7. Okay, we have to reach 7. We are starting from 3. Correct. So 3 square is how much? 9. 9 minus 2 is 7. So randomly I put this. But first one, if you see, that may not work. First one we have 1. So I'll do 1 square. 1 square is 1. So we have plus 2. 1 square plus 2 is 3. 3 square minus 2 is 7. Hope it works. Next we have 7. 7 square. 7 square is 49. We have to reach 51. Correct. And then difference is again plus 2. I'm assuming this pattern holds good. What exactly is happening over here? We are squaring the number and we are adding 2. Next we are squaring the number. We are deducting 2. So from plus 2 it has gone to minus 2. Okay. So the pattern so far, plus 2 minus 2 plus 2 minus 2 after squaring the numbers. So in that case 51, we'll have to square 51. Correct. How much is that? 51 into 51, 2601. 2601, and we have minus 2. 2599. 2599. We do have that. So I think the logic is holding. There are only 4 numbers given. If there are more numbers, it would have been easier to establish the logic, but then it is working. Option is there, has to be the right answer. Option B is the right answer. Moving on to the last question, and the last question that we have in number series. Okay, question number 22. We have 1, we jump to 6. Addition, multiplication, by now we know squares, these are the ones which we are using. And then we have after 6, we are jumping to 21. Okay. 6 to 21, if I see the ratio, it is little more than 3, 3.5 maybe. And then we have 66. So if I take 66 and divide by 21, that is also very close to 3, little more than 3. First it was 3.5, but this is not 3.5, something close to that. Then we have 201, again close to 3. So we might have to multiply with 3, then we'll do the adjustment. So first we have 1, we have to reach 6. We'll multiply with 3. Okay, after that we'll add 3, so we get 6. Okay, let's see what happens after that. After that we have 6 into 3, which is 18, plus 3, 6 into 3, 18 plus 3 is 21. That also holds good. So maybe it is into 3 plus 3 into 3 plus 3. Let's check. 21 into 3, which is 63, again plus 3, which is equal to 66. Absolutely. So we have 66 into 3, 198 plus 3, which is 201. So the logic is clear. We have into 3 plus 3 into 3 plus 3 into 3 plus 3 to the previous number. We have 201 into 3 plus 3. 201 into 3 is 603 plus 3 is 606. We do have that option in B. That's the right answer. That's a number series. So what did we learn so far in number series? We have addition, we have subtraction, we have multiplication, we have division. The general pattern is when the numbers are increasing, we go for addition or multiplication. When it is reducing, we go for subtraction and division. And also if the numbers are increasing at a exponential rate, we square them, we cube them, and also after that again addition, subtraction, and the combination of all of this. We also used prime number in one of the questions. So these are the different questions that we have in number series. And this is the first unit under this particular chapter. This chapter includes number series, coding, decoding, and odd man out. So we'll move to the next unit now, coding and decoding. Here what we do is we have a secret number. Okay, what we do is we associate each letter of English alphabet with a particular number. For example, now A, the first letter of English alphabet is equal to 1, second letter B is equal to 2. I believe we know the letters of English alphabet, correct? We definitely remember the nursery rhyme A, B, C, D, E, F, G. Okay, so if you don't remember, let's go in that tune and get the numbers associated with it. So we'll need to remember few of the letters because from there we can always continue. Okay, so we have letter A, the first letter. Okay, we will give it as number 1. Then the next I want you to remember is E, which is number 5, because if I have F, E, F, so we know that it's 5 plus 1, 6 and so on. Then I want you to remember J for Jason, my name. Okay, so we have number 10, and then we have number 15, and then we have T, which is 20, and then the last one Z, which is definitely 26. These will remember, and then we can always take the next number. For example, now if I want to know what is K, J is 10, H, I, J, K, L. So J, K, L, so K is 11. Or if I want, let's say R. So what do I know the letters before R or after R? We have O, M, N, O, P, Q, R. So 18. Or we can start from T also, which is T is 20. And you know, 2 letters before that is R, R, S, T. So that way we will remember. This much I want you to remember. Not every time we'll be associating these numbers only. Sometimes we will take 1 plus, 1 minus, or so on. So depending on the question, we need to get the logic and the pattern for this coding and decoding. Now let's go to the questions and see what exactly the questions will ask you to calculate. Fine. Question number 23, the numbering continues. We have S, C, D. We have T, E, F, U, G, H. A blank the answer, and we want W, K, and L. Try to find the pattern. Okay. So we have S. So if you see the second one, we have T, S, T, U, and W. Okay. Let me just highlight that. Fine. So we have S over here, S, T, U, and one is missing, W is there. So if you go by the letters M, N, O, P, Q, R, S, T, U, we should get V. The next letter here, missing one is V. U, V, W, X, Y, Z. Okay, fine. Next we have C over here. Next letter, let me just change the color for this one. Okay, let's go for blue. Okay, so we have C over here, C. Okay, after that we have E. So it's not the very next letter. From C we have E, A, B, C, D, E. So second letter after that. So we have left one letter, C, D is not there, E, F is not there, G. So in that case, after G we have H, high. The next letter should be high, V, I, which is there in only one option. Option B is the right answer. But if you want, we can check the next one also. Next letter D. After D we have F. So what do we get over there? A, B, C, D, E, F, G, H, I, J. So it should be J. V, I, J is the missing code for us. So we are getting the sequence of coding also over here. In the number series, it was numbers. Here we have letters. Also, we will have some numbers later on as well. Basically, we are getting codes in this particular unit. Question number 24, we have Q, P, O, N, M, L, K, J, I, H, G, F. See only the first letter for each sequence, okay? Each term, in fact. Okay, so if you see, we have Q and then we have N. So we are getting the letters in the reverse order. And we have K, we have H. So what are the number of letters? Is it the very next letter? No, it is not. So we have H, I, J, K, L, M, N, O, P, Q. So 3 letters before. 3 letters before. If I start from here, it's 3 letters before. So which is that letter which is there? 3 before H. A, B, C, D, E, F, G, H. Not G, not F, E. So E is there only in first option. So I get the first letter is E. That is 3 letters before H. This one is, okay, we'll put it this way, 3 letters before H is E. Okay, next we have P, M, J, G. Here also it is going backwards only. It is going backwards. So if you see G, H, I, J, K, L, M, N, N, O, P. Correct? So again it is 3 letters. So we will go back now from G, 3 letters backwards. What is that now? A, B, C, D, E, F, G. So the letter before that is D. Okay, 3 letters before. And the next one, if you see M, N, O, P, Q, R. So it's again going backwards on the F, F, E, F, G, H, I, J, K, L, M, N, O. Again here also it is 3 only. Okay, here let me write this over here. 3 letters before G. Okay, and here we have 3 letters before F. 3 letters before F is C. We have the answer A. So everywhere we are taking 3 letters before the one which we had in the previous one. That's question number 24. Hope it's clear. 3 letters before. Question number 25, we have 1, 2, 3, 4. So next should obviously be 5. Okay, so I get 5 the consecutive numbers, and then we have A, B, C, D. So it should be A, B, C, D, E, and we have now the reverse order Z, Y, X, W. So what is the letter before that? So we have V, U, V, W. So we are just taking first. The character should be a sequence of the numbers 1, 2, 3, 4, 5. Second one is the letter. Third one is the reverse letter. So 5EV is the right answer, which is there in option A. Question number 26. We have D2E and then we have H4J, L6O and P8T. So what are we doing over here? First we'll check the numbers so that we can eliminate the options. We have 2, right? Okay, we have 2, 4, 6, 8. The middle number we have 10. So it should be 10 for sure. Okay, so 10 is there over here, 10 is there over here. It's either A or it is D, 10 in the middle. Then we have D from year to year. A, B, C, D, E, F, G, H. So 4 letters later. So we have plus 4 letters over here. H, I, J, K, L, M, N, O, P. From here also we need to add 4 letters. P, Q, R, S, T. So 4th letter over here is T, which is there in option A. I'll tick for the time being. Let's confirm after we check the third character as well. So we have E. The third one is E. E, F, G, H, I, J. E, F, G, H, I, J. K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y. So we have Y as the answer. So we have option A to be the right answer. Moving on to the next question. Okay, I've not written that. No, why? Okay. So anyways, that was anyways the only option that we had after satisfying for the first 2 characters, 3 characters in total. Anyways, question number 27. Okay, moving on to the next question, question number 27. If Madras is coded as, there is a word which will not be able to read, how Delhi is coded in that particular code. Fine. Let's see what is the connection here. M, we have the first letter, and here if you see the first letter, we have N. See the connection from here to here. We have the very next letter, right? N comes after M. Then we have E, next letter is B, so it is matching. Then we have D, next letter is E, and then we have R. For that we have S, for A we have again B, and for S we have T. So if you see, it is the immediate next letter that we see in the code. So for Delhi, how Delhi is coded in that code, what should we do? Should we take the next letter or should we take the previous letter? Yes, we should take the next letter. So from D, the next letter will be E, correct? E comes after D. For E, what comes after E? E, F, correct, E, F. Then we have L. What comes after L? J, K, L, M. M comes after L. Then we have H. H high, J, K, and then we have high. For high we have J. And where do we see this? E, F, M, I, J. E, F, M, I, J. It is there in option B. Option B is the right answer. Correct? That's question number 27. We'll move on to the question number 28. Raman is written as 1, 2, 3, 4, 5. Dinesh is written as 6, 7, 5, 4, 8, 9. They have made some coding. How Aman is written? So this time it won't work as to the numbers that we had associated the letters with. So they have given a different coding. Fine. So they're saying R is to be written as 1, A is to be written as 2, M is 3. In fact, I read it as 1, 2, 3, 4, 5. No, it is 1, 2, 3, 2, 5. Okay. Again, A is there. See, again, A is associated with the same number which was there earlier. So it is 2. And then we have N. N is 5. Further, Dinesh is also there. I will write D is equal to 6. I is equal to 7. N is equal to 5. Okay. And we have E equal to 4. S equal to 8 and H equal to 9. So these are the numbers that are given. How is Haman written? H-A-M-A-N. Let's try that. Okay. H will pick from the above. H is 19. Correct, no? Sorry, 9, not 19. 9. Okay. And we have A. A is 2. A is 2. Okay. Then we have M. M is, we had written it somewhere. M is 3. M is 3. And we have A again, which is 2. And M again, which is 3. Do we have this? 9, 2, 3, 2, 3, 9. Be very careful. 9, 2, 3, 2, 3. Which is there in option A. Option A is the right answer. So the number is given. We have to see what number is given and accordingly apply the same number for the next coding. Fine. That's question number 28. Moving on to question number 29. If red is coded as 6720, green is coded as... Okay. Any connection that you see? 6720. D's number is how much? 4. Okay, but we don't have 4 over there. We have a 6 number somewhere. Okay, let's see. E. What is E equal to? Normally E is equal to 5. Correct, but do we have 5 over here? No, we have 7. Okay, next we have R, right? R. R's normal number is T is 20, we know. R should be 18, 2 letters before that. So the numbers that we normally know is the associated letters. D is equal to 4. We have E equal to, normally it is 5, and R is normally equal to 18. Correct? But what they have done is they have added 2 over here, added 2 over here, added 2 over here. We get 6, we get 7, we get 20. So the logic is the letters number of that particular letter in English alphabet plus a 2 to it, but in the reverse order. If you see over here clearly, D is the last letter, but here it is written first. So we'll do the same thing over here. Fine. We start with N. Okay. N. What is the number of the letter N? J, K, L, M, N. 14. 14, but I have to write 14 plus 2 equal to 16. Correct? Plus 2 is added. Next we have is E. E normally is 5 plus 2 should be 7. 5 plus 2 equal to 7. So 16, 7. Okay, it's there in quite a few options. Then again we have E. So another 7 for the second E. And we have R. Remember, it's in the reverse order. R is equal to how much? R, S, T. R is 18, which we had decided earlier as well. Plus 2 should be 20. And after that N, which is 14, we should get 16 as the answer. So if I join these numbers together, we have write it together. 16, 7, 7, 20, and oh, in fact, this is not N, okay, this should be G. Sorry, I was seeing the wrong letter. It was G. Okay, so G's normal number is how much? A, B, C, D, E, F, G. G is 7. So 7 plus 2. 7 plus 2 equal to 9. Okay. So the last number should be 9, which is there in option C, 1677209. That's question number 29. I hope it's clear. Here what we have done is we have taken the letters and then we have added 2 to it. Great. Question number 30. A is given as 1. Okay. Others also we normally take A to be equal to 1. Fat is given to be equal to 27. But F is normally 6, right? 6. A is equal to 1. T is equal to, normally it is 20. So it's 20, there is 1, there is 6. And the number given is 27. So no, 20 plus 6 plus 1 is just 27. So let me find the logic. A is given to be equal to 1. No problem. We don't understand the exact logic. FAT, number of letters. We have 6 plus 1 plus 20, which is equal to 27. So what we have to do over here is find the number of the letter and then add them. Great. So with that we should be able to find out what faith is totaling to. What is F equal to? F is equal to 6 plus 1 plus what is I equal to? H, I, J. J is 10, so this should be 9. Okay, what is T equal to? T we know it's equal to 20 and H is equal to 8. Let me add this now. 6 plus 1, 7. 7 plus 9, 16. 16 plus 20, 36. 36 plus 8. 36 plus 8 is 44, which is there in option A. Option A is the right answer. If lose is coded as 1357, gain is coded as 2468, what will 42146 stand for? Okay, so it's now reverse. Like they have given what is what, and now numbers are given to define letters. Fine. L is equal to 1 for us. L is equal to 1. O is equal to 3. And S is equal to 5. E is equal to 7. So those are the letters that are associated directly, direct relation. Okay. And let's see if it will work. We have 8. 8 ke liye, what do we have? For 8 we have, where is 8? 8 is there for gain, right? For gain it was there and it was the last one. So it is equal to N. Okay. Eliminates 2 options. We have only A and B with N in it. And then we have the next number 2. 2. Where was 2 for me? Where 2, 2, 2. 2 is the first one over here, which is G. So NG, which is there again in both the options. Next we have 1. Where did we have 1? 1 was over here. 1 is L. Okay. And then we have 4. What is 4 now? 4, 4, 4. 4 is here. 4 is here. A is there. A is equal to 4. We have the answer. Answer is A. Anyways, we'll continue. We have 6. The last number is 6. 6. Where is it over here? I. NGLAI. Naglai. Okay, doesn't make sense, but anyways, that's what it is. Question number 31 done. 32. If in a certain code language name is written as 4258, what is coded as mean? So if you see the letters in mean and letters in name, both are same. Correct? So we'll just have to rearrange the numbers. N was equal to 4 and here N is there last. So we have 2 options with having 4 at the end. Okay. And here we are starting with M. M is over here. 5 is associated with M. So we have 5. So I think the answer is 5824. 5824. I've explained that. I'll write it again. Okay. For N we have N is equal to 4, we have A equal to 2, we have M equal to 5 and we have E equal to 8. So in that case mean we have 5 MEAN. So we have 5, E is equal to 8, 5, 8, E is equal to 2 and N is equal to 4. 5824 is the right answer. Option D is right. Okay, question number 33. Gold is written as IQNF and wind can be coded as. Fine. So let's try to get the connection. Okay. Gold. For G we have I. Any connection between the letters? A, B, C, D, E, F, G, H, I. So 2 letters after that is red. Okay, let's see. O is there. What comes after O? M and O. P, Q. Again 2 letters after that. L. M, N, L, O, P. Correct, right? M, N. Sorry, L is there. L, M, N. Again 2 letters after that. And last we have is D. After D, again 2 letters if you take, you get E and F. So what we have to do is, we have to take the 2 letters after the letter that is there for gold. That's the coding over here. So for wind, what do? We'll take the 2 letters after W. What comes after W? 2 letters R, S, T, U, V, W, X, Y. So we have to take 2 letters after the letter. Okay. W के लिए we have I said R, S, T, U, V, W, X, Y. Y is there. Okay. And then for I, F, G, H, I, J, K, N, M, N, O, P. And for D, we have 2 letters later, which is equal to F. So answer is YKPF. Answer is option A. Question number 34. If rose is written as TQUG, biscuit can be written as. So some connection we'll have to see over here also. Okay. R, S, T, O, P, Q, and then we have S, R, S, T, U, V, and then for E we have F, G. So it's always the 2 letters after that. So if you consider biscuit, so we'll take 2 letters after the letters of the word biscuit. What comes after B? A, B, C, D. So we have to start with the D, 2 letters. So plus 2 letters. We have B के लिए D. Okay. I, H, I, J. Just a minute. Okay. Rose. We have 2 letters R, S, T, B, C, D. Okay. H, I, J, K. Sorry, it should be K. J, K. 2 letters later. Okay. And then for the next letter S, R, S, T, U. U. 2 letters afterwards is U. And next we have is C. After C, D, E. So we get E. Okay. By now I think the answer is there. Answer is A. But let's confirm. Okay. After that we have U, V, W. And we have I. For I we have J, K. Okay. And for T, U, V. Again we have the answer. Option is A. So we just have to take 2 letters after U1 over here. Question number 34. Answer is A. Next question. Question number 35. If Delhi is coded as CCIDD, how would you code Bombay? So let's try to get the relation over here. For D, we have the immediate previous letter, right? C. Okay. But may not be the case, because for the next one, E, again we have C only. For E also we have C, but that is 2 letters before that. L ke liye, for L we have I. What is the difference between L and I? H, I, J, K, L. So now the difference is 3. H, for H difference is 4. So the difference is increasing, right? So first we take immediate 1 letter backwards, then we take 2. So we have -1, -2, -3, -4 and -5. That's the logic over here. So for Bombay, I'll write that BOMBAY. So it should be -6 after that. Okay. Fine. First one B, 1 letter before that is A. -1. I'll write over here is A. Okay. O, 2 letters before O. J, K, L, M, N, O. So in that case it will be M, right? Yes. So here we have -2 letters. We have -3 for M again. Now for M, the letter before that is, we'll have to check J, K, L, M. So in that case it will be J, correct? J, K, L, M. For B, to 4 letters before B. Now you may think before B we cannot have 4 letters. We can go back to Z. Okay, so we'll take 4 letters before that. So we have A, 1 letter gone. Last letter is Z, that is gone. Y is gone, and one before Y is X, XY, correct? Okay, so you'll have to go to the previous one also. -5. Okay, so 5 letters you remove. A is the first letter, so remove from the last one. Okay, if you remove 5 letters, you get V. Okay, and then last one we have Y. From Y we will have to reduce 6 letters. From Y we will have to reduce 6 letters, and we get yes, -6 letters. So here it's not the same pattern that is followed. The difference in the letters keeps on increasing as we go further and further. Moving on to the next question. If PALAM could be coded as 43. Something similar we have done earlier also, correct? We'll try to use the same logic. P will take the letter that is associated with these, we'll take the number that is associated with these letters, that is the number in the English alphabet, and then we'll try adding. We did that once, remember? It was A equal to 1, fat was there, something like that was given, faith is what we had to calculate. So we'll try this same logic. What is P equal to? M, N, O is 15, OP is 16. Okay, fine. We have A is equal to 1. We have L equal to 12, right? Yes, A is equal to again 1, and M is equal to 13. Let's add this. 16 plus 1 is 17, 17 plus 12 is 29, 29 plus 1 is 30, 30 plus 13 is 43. So the logic holds good. We have to take the summation. We have to add the number that is associated with the letters. Now we'll have to go for Santa Cruz. SANTA CRUZ. Okay, fine. So first we start with S. What's the number for S? 19. What is A equal to 1? What is N equal to? 14. T equal to 20. A equal to 1. C equal to 3. Okay. R equal to 19. Sorry, 18, right? 18. And U, RST, UV. So it is 21, and Z is equal to 26. So let's add this. We get 19 plus 1 plus 14 plus 20 plus 1 plus 3 plus 18 plus 21 plus 26. 123 is what I get in my calculator. That's there in option A, the right answer. Question number 37. Now this question is slightly different. Okay. 256 means you are good. Okay. 637 means we are bad. Also, 358 is given to be good and bad. So if you see, some words are repeated from first to second, some are repeated from first to third, and some are repeated from second to third. So different combinations we will have to check. Let's see what we get from first one and the second one. What I'm underlining right now, R is there in the first sentence, R is there in the second sentence. Okay, and what is the common number that we have? We have 256, we have 637. So common is 6, right? 6 is there here, 6 is there here. In that case, what I'm concluding is R is equal to 6. I know it is not in the same order, but it's okay. Okay, we have good over here. This time I'll put a circle, good over here. I have good over here also. Okay, and what is the common number? We have 5 here and we have 5 over here. That means good is equal to 5. Good is equal to 5. What else? We are bad. Bad is there in the second one. Let me change the color now. Fine. Bad is there here. Where did it go? Here. Here there is bad, and here also there is bad. And what is the common number this time? We have 3 over here, 3 over here. That means bad is equal to 3. Bad is equal to 3. So what is remaining? 8. So what is and equal to? This part, and is equal to 8. So and is equal to 8, which is there in option C, and is there in 8, which is there in option C. That's the right answer. So little different over here. It's not even in the same order, but from the clues that are given using the logic, that's all it is about in logical reasoning. Using logic, sometimes even logic does not make sense. Yes. If monkey is written as X, D, J, M, N, L, how is tiger written? So one logic is given to us directly, the next word is asked. So some connection has to be derived from the word monkey to the coding that they have given. And if you directly see, we have M ke liye X, not very nearby letters, and even the next letter if you see we have O and D, not very near. But what is near is the first letter and the last letter of the code. First letter of the question is equal to the last letter of the code, O N. So it is very close. What is the closest, or what is the difference in the letter L and M? They are very consecutive letters. So we will take one letter before that. If you see M, we have L, we have O, one letter before that is N, N, one letter before that is M, K, one letter before that is J, and so on. So what we'll do is we'll try with the tiger, one letter before. I've written tiger. What is the letter which comes before T? Yes. So this should be the last letter. Okay. What comes after before I? It is H. What comes before G? F. What comes before E? D. And what comes before R, right? R is remaining. No, yes. R, what comes before R? It is equal to Q. Q, R, S, T. And where do we have this in the option? We have Q, D, F, H, S in option A over here. And that's the right answer. So we'll move to the last part of this particular chapter. Odd man out. Like it says, there will be certain numbers that are given, or maybe sometimes even letters, and sometimes something else where we have to find out something which is different from other. Like it should be unique. One of the terms will be unique, and that's what we're trying to find out. The patterns will be different, the logic will be different. What we can think of is some odd numbers, even numbers, prime numbers, cubes, like whatever we have done so far, squares and so on. We'll try to find the logic as much as possible. We'll take the questions, few questions that are there. Find the odd one out. We have 3, 5, 7, 15, 17, 19. If you see carefully over here, do you find something weird about any particular number? From what I see, all are prime numbers, right? So 3 is a prime number, 5 is a prime number, 7 is a prime number, 15 is not, 17 is a prime number, and 19 is also a prime number. So other than 15, all are prime. All are prime numbers other than 15. So we'll go with it. 15 answer is A. Perfect. Next question number 40. We have 10, we have 14, 16, 18, then we have 24 and 26. So what is missing? This is an odd number. Also, I think there is a particular sequence also. 10 plus 4 is 14, 14 plus 2 is 16. May not be the sequence, plus because again we have plus 2, 18. And then it should have been either 20, 22, one of them. Then we have 24 and then we have 26. But whatever it is, 23 is an odd number. We'll pick 23 to be the right answer. Next, moving on to question number 41. We have 1, 4, 9, 16. By now we know these are perfect squares. So other than one number, all are perfect squares. 24, not a perfect square. Should have been 25, but no, we have 24. All the other numbers are perfect squares. Question number 42. Okay, so if you see this sequence 1, 5, 14, and then we have 30, 49, 55 and 91. Correct? So the numbers are jumping. But if you see, there is a little bit of difficulty in finding the odd one out. Like we have ruled out with these odd numbers, even numbers, prime numbers, all these options are ruled out. I was thinking of squares, but 1 is a perfect number. Other than that, I doubt. But if you see the next number, when I was preparing also, when I took little bit of time over here. So 5. 5 is not a perfect square, but the closest we have is 4 square. So I thought 2 square. 2 square is equal to 4. And then we add the previous number, which is equal to 5. Let's see if that logic holds. If you take 3 square, 3 square is 9. 9 plus the previous number is 5, which is equal to 14. So maybe this is holding good. Let's try this. Okay. We have 1 square plus the previous number, which is not given to us. So we'll not consider that. We'll take the second one. Okay. We'll have 2 square. 2 square is 4. 2 square is 4 plus 1, which is equal to 5. Next we have 3 square plus the previous number. 3 square is 9. 9 plus 5 is 14. So that holds good. 4 square plus 14, the previous number. 16 plus 14 is 30. Okay, so the pattern is holding good. Let's try now 5 square plus 30. 5 square is 25. 25 plus 30 is 55. So 49 went missing, but let's confirm. 6 square plus 55. 6 square plus 55. 6 square is 36. 36 plus 55 is 91. So we have got it. Correct? We have 5, 14, 30, 55, 91. First was the first number. 1 was the first number. The only one which was not holding the logic is 49. And that will be our answer. We'll go ahead with 49 to be the right answer. So the logic over here is we are squaring and then we are adding the very previous number. One number was extra, which is 49. Moving on to the next question. Question number 43. Here we have 835, 734, 642. Okay. And then we have 751, 853, 981. Correct? Okay. So trying to find the logic. Now there is one more number, 532. 532 is also there. So we'll try adding these numbers and see what we get. If you have 8 plus 3 plus 5, 8 plus 3 is 11, 11 plus 5 is 16. Okay. We have 7 plus 3 plus 4, which is equal to 14. Next we have 6 plus 4 plus 2, which is equal to 12. And then we have 7 plus 5 plus 1, which is also equal to 13, which is equal to 13. Okay. And then we have 8 plus 5 plus 3, which is equal to 16. Correct. And we have 9 plus 8 plus 1, which is equal to 18, and 5 plus 3 plus 2, which is equal to 10. So if I add, this is what I get. Now let me see if there is any connection. If you see, all these numbers are even numbers other than 13. Correct? So 751 is the right answer. Okay. Next question. We'll go to question number 44. Find the odd one out amongst these. 52, 51 is there, 48, 43 is there, 34, 27, 16. So first we always check odd numbers, even numbers, prime numbers. We'll do that. Even we have 16, we have 34, ruled out. Two numbers are even. Odd numbers we have 51, 43. That logic is also ruled out. Prime numbers. First you check prime numbers, eliminate even numbers. Other than 2, all even numbers are not prime numbers. So we have 52 gone, 48 gone, 34 gone, 16 gone, 27 is not a prime number, we know. Correct? 9 into 3 is 27. 51 is remaining. 51 is also not a prime number because 5 plus 1 is 6. And we know when we add the digits and if it is a multiple, then that 51 is divisible by 3. So 51 is divisible. But 43 is not divisible. Correct? So prime numbers is the logic. Prime numbers is the logic. Answer is 43, which is there in option C. Question number 45. So we're going to the months now. we have March, May, September and December. So what do you know about these months? So there is March, there is May, there is December and also September. If you remember, we do this, right? Checking which month has how many days. So we'll see Jan as 31, Feb if you see as less days, 28, 29. March we have 31, April, May 31, June, July 31, August again 31, September as 30, October 31, November, December also 31. So if you realize, March as 31, May as 31, December as 31 and September as only 30 days. September as 30 days. Other months are having 31. Other are having 31 days. So I'll go ahead with September as the right answer. 46. Find the odd one out. This is also the last question from this unit. Okay, done. 2, we have 3. 4 by 3, 1 by 2. And then we have root 3. But you must have already guessed because we have number system done in mathematics. So we have 2, 3, 4 by 3, 1 by 2. The types of numbers that we have natural numbers, but it won't hold good. We have whole numbers, won't hold good because we have 4 by 3. 4 by 3 is not a whole number. We have integers, integer also won't hold good. Then we have rational numbers. If you see rational numbers, we have 2 is a rational number, 3 is a rational number, 4 by 3 is a rational number. What is a rational number? Rational number is a number which can be expressed in the form of P by Q. Rational numbers. P by Q. So which one is not? Root 3 is an irrational number. And that's the right answer. So that's it. That's all that we have in odd man out, okay, or odd one out. So 3 units were there in this chapter. First was about the number series, where we took addition, subtraction, multiplication, division, squares, cubes and combination of these things. Then we came to coding, decoding with letters. We associated numbers with letters, sometimes with words. And last we had to find out one particular term which is different from the other numbers, that is odd man out. Every time the logic will be different. As you solve more and more problems, you will get the hold of it. Fine, that's all that is there in this particular chapter. I'll see you again in the next chapter. Thank you so much.